Assalamu alaikum. Let's wait for people to join. So Facebook ने मुझे you are a rising star कह दिया जी, and you have already made an impact on the group within your first month by making posts that people appreciate. Your rising star badge will show up next to your name on comments and posts. Wow. और ये सब आपकी वजह से है. शेर सुना दे. एक रात को मैंने शेर कहा है. Let me share that share with you. वो है, हाँ, दफ्तर से आके भी दफ्तर लगा है, मुलाकातों का भी वही सिलसिला है, कहता है कौन के लॉकडाउन हैं हम, घर में ही सारा शहर बस गया है. और आपका तो घर में ही सारा कॉलेज लगा है. Okay, so let's start learning about Z transform, and so we are Z transform and learning about the properties. And we have learned several properties. Last time we were discussing differentiation property. And differentiation property is that if you multiply a signal by n, then in Z domain, it is differentiation. Okay. हाँ जी, दूर तुमसे हो गया हूँ, रास्ते में खो गया हूँ. And then there is another property which is time reversal. And time reversal, as we have this property in the Fourier transform as well, it simply says if you flip in time, you flip in Z domain. So Z will be replaced by 1 over Z. So it's a simple property. Z will be replaced by minus Z. For example, we know the Fourier, the Z transform of A of n, U of n. And it is 1 over 1 minus A Z inverse. Okay. And with Z magnitude is greater than A magnitude. Now if you replace A by minus A, n by minus n, so Z transform is very simple to compute. You replace Z by minus Z. So this is the Z transform, and 1 over Z magnitude is greater than A magnitude, means 1 over A magnitude is, so Z magnitude is less than 1 over, and we know that once we have a left hand side sequence, its region of convergence tends inward. So this is an important property to learn, but we have seen it in a discrete time Fourier transform as well. Next is the convolution property. Again, very important property. And we also know this, right, from a number of courses, that convolution in time multiplication in Z domain. So this is also an important property. Convolution in time is multiplication in Z domain. Now the important part. Important part is that what is the relationship between Z transform, and Fourier transform? Relationship between Z transform and Fourier transform. This is an important relationship, and that tells us a lot. As we know that Z transform, we introduce this R, and then we take the Fourier transform. This is how we learned about the Z transform, right? So what is the relationship between Z transform and Fourier transform? It's very obvious. If R is equal to 1, then Z transform becomes Fourier transform. Obviously, once R is 1, then it remains A of n exponential minus j omega of n, which is the Fourier transform. So we can write it like this, that x exponential j omega is equal to x of z, where R is equal to 1. Okay, so very, very important relationship. A very important relationship. So why come it is an important relationship? One is that given Z transform, you can find the Fourier transform in exams. For example, if I tell you that, and not really, okay? So for example, if I tell you if Z transform is 1 over 1 minus half Z inverse Z magnitude is greater than 1 over 2, and question is, what is the Fourier transform? So you don't need to take inverse Z transform, find out x of n, then take Fourier transform. You know this relationship. Just replace Z as you know Z is R exponential j omega, put R is equal to 1. So once you put R is equal to 1, it becomes, Z becomes, or Z inverse become exponential minus j omega. That's it. So wherever you find Z inverse, replace it with exponential minus j omega. So x exponential j omega is going to be 1 over 1 minus half exponential minus j omega. So simple. So you can easily find out the Fourier transform given is Z transform. But then I said not really. So where the not really part comes. So let's see this. Not really, not really, not really, not really. If I give you a Z transform, which is 1 over 1 minus 2 Z inverse, and Z magnitude is greater than 2, then I cannot say that x exponential j omega is 1 over 1 minus 2 exponential minus j omega. Wrong. Sorry, with red. Wrong. Why? So, can anybody tell me why this is not true anymore? T. Anybody? Why this answer is correct and this answer is not correct? Anybody? Yes, unstable signal, but still why? So the reason is here. It says R is equal to 1, then Z transform is Fourier transform. And Z transform, as you know, is valid for a range of values. A range of values. Yes, no, it's not stable, but we need to exactly find out the reason. Okay, the reason is that Z transform is a special case, a Fourier transform is a special case of Z transform when R is equal to 1. Okay, a special case once R is equal to 1. Here, once we say Z magnitude greater than half, so if I draw this is 1. So a circle with 1 is very important in signal processing. This is circle with 1. And the region of convergence in this case is half. This is half. Okay. So this answer is valid for all this region which includes the unit circle. Okay. So that's why we say it's not diverging, but the reason is if your unit circle where the Fourier transform becomes the Z transform, it is in the region of convergence, then we say you can write this answer. Otherwise you cannot write this answer. Yes. Here in this case, once you plot its region of convergence, so its region of convergence is, so you need to plot the circle. So plotting this circle is important. This is a circle where Fourier transform exists. This is R is equal to 1. But the region of convergence is outside the circle too. Okay. So the validity of this expression is if the unit circle must have, the region of convergence must contain the unit circle. So region of convergence becomes very important. That plotting the region of convergence is very important because that will only tell you whether the Fourier transform exists or not. And why should I worry about Fourier transform? Okay. So all I am saying that once you are plotting the region of convergence, this circle has a value, and in every book, MATLAB, any paper you find, you will find this circle very uniquely drawn. This circle of radius 1 is drawn even in MATLAB once you are designing your system or doing whatever. This circle with unit radius in Z-plane, complex Z-plane. So this is Z-plane. We call this Z-plane. Why it is Z-plane? Because here is R, this is omega. So this point is Z, which is R exponential j omega. Okay. For different values of R, different values of omega, you have this. This is important. Then once you plot the unit circle, the region of convergence, if region of convergence contains the unit circle, we say Fourier transform exists. Okay. Fourier transform exists. If region of convergence contain, ये पेड़ जिस तरफ होता है ना, contain the unit circle, okay, Fourier transform exists. If it does not contain the unit circle, then Fourier transform does not exist. But why should I care about this? I don't really. But I do care about the stability. And we know that Fourier transform only exists of stable system. Okay, Fourier transform, I should say, only exists for stable system. It means for stability, the same constraint for stability. That is, if region of convergence contain unit circle, system is stable. This is a this is why we take Z transform. Okay, I told you the reason earlier that we take Z transform only to figure out whether system is stable or not. So now we have a condition, and which says if region of convergence contain unit circle, system is stable. Okay, and how do we figure out the region of convergence? We have seen that if there is a system which has 3 poles, we did this exercise like last time, A, B, C, and every pole means an exponential, right? So this is a system which h of n is a of n, u of n, plus b of n, u of n, plus c of n, u of n. This is h of n. Okay. And its region of convergence, and I said you have to draw the unit circle with red color. Unit circle with red color. So this is a default. No matter what you have, you draw it with unit circle. You know, if it is right hand side, all three are right hand side sequences, then region of convergence is outside the outermost pole. This is the region of convergence. Okay, this is the region of convergence. So if it's a very interesting conclusion we can draw from this figure, that if the outermost pole of a right hand side sequence, right, is inside the unit circle, then system is stable. Means कि जो the maximum magnitude pole is less than 1, we say system is stable. So for causal system, and that's what we care usually in practical signal processing for causal. Causal means all right hand side sequences in the impulse response. For causal system, okay, if the outermost pole is inside the unit circle, system is stable. So important, very important property, that if for a causal system, if the outermost pole is inside the unit circle, then, and how about the anti-causal system? Obviously it will be the inverse. Like if the innermost pole is inside the innermost pole is outside the unit circle, then the system is stable, right? If the innermost pole, because the region of convergence for left hand side sequences inside the innermost pole, this is the region of convergence. So the unit circle, if it is here, then system is unstable, but if it is here, system is stable. So we need to just watch the positions of the pole. If position of the poles are such that the region of convergence contains unit circle, we say a system is stable. So now we know a very important property of signal processing, which really helps us to tell us about whether system is stable or not. Still, we need to establish that how do you figure out the poles, and let's now do that. Okay, that is the second important part, that okay, we understand, but how do you figure out about the poles of the system? So usually you are given a difference equation, not the impulse response for IR filter, difference equations for IIR systems, a difference equation. So a difference equation for IR system looks like this: y of n is equal to a y. If it is the first order, this is the difference equation. Okay, then what you do is you take the Z transform of both sides for finding out whether all the poles are inside the unit circle or not. So you have to take the Z transform of the difference equation. Once you take Z transform, you get y over z is equal to a z inverse y of z plus x of z, then you have take y of z common, you get outermost pole is 1, then it is unstable system. A pole right on the unit circle, because the region of convergence cannot contain a pole, it becomes unstable. Okay, whether it is right hand side or left hand side, a pole on the unit circle means that you are gone. So y of z is 1 minus a z inverse is equal to x of z. Y of z is over x of z is 1 over 1 minus a z inverse, and we know yz over xz is h of z is equal to 1 over 1 minus a z inverse, and we know where is the pole. Pole is at a, whatever is the value of it, and then you draw the unit circle. So if a magnitude is less than 1, then the system is stable. Okay, so this is h of z is 1 over 1 minus a z, and z magnitude is greater than a magnitude if we are assuming a causal system. So this is how we figure out the stability of the system, but usually the equation given to you will be something like this: y of n plus a1 y of n minus 1 plus a2 y of n minus 2, like we have seen in the Fourier transform as well. And you have b naught x of n. So usually this is how the difference equation is given. So bm x of n minus m. Okay. So once you take z transform, we know the z transform expression for the transfer function will be h of z is 1 plus a1 z inverse plus a2 z minus 2 b naught plus b1 z inverse, and I'll go like this, bm z minus m. So you get a polynomial in the numerator and a polynomial in the denominator. So if you find poles of or roots of the numerator, these are the zeros. If you find out roots of the denominator, these are the poles. So you find out all the poles, all the roots, like they are going to be n roots. ठीक है? तो आप देखेंगे even in MATLAB, whenever you design an IAR system, the order means these many poles. Okay, so once you plot the pole 0, so you will see if there are like 10 of these, so you will find 10 of the poles somewhere. Okay, so it is very important for us to draw the poles and the unit circle. If poles are all inside the unit circle, we are okay, we say system is stable. If any one of the pole goes outside the unit circle, we say system is not stable. Okay. अच्छा, इधर I have another call, जो मुझे conference call है. We are trying to make Islamabad as knowledge capital of Pakistan. So I'll take a break and we will restart at some time, and Dr. Ali will coordinate that when are we going to start, another 25 minutes. तो आपको मैं दोबारा से इंशाल्लाह we'll see each other again, and we'll just try to finish this part of the Z transform, which is the fun part actually. Okay, how from a difference equation you figure out whether system is stable or not, which is why we studied a Z transform. So I'll see you after 25 minutes. Oh no, I see you after some time. Okay, thank you. If A is equal to 1, it is unstable. Thank you.